Good evening. My name is Maxim Smirnov, and there is no any jokes like about my last name all the time, but like vodka.
And Maxim, like the magazine.
No, it's like Maxim. It's not funny. The previous one was better. But okay. Yeah, have you know that Smirnov vodka is British one? It's not Russian?
It's terrible. It's also terrible.
Okay. Some history. Okay, today we're going to talk about refactoring, but only like about some basics and introduction into this stuff, because one main of my goals is just to synchronize community and describe what refactoring really is. So I'm going to start with a story. Once upon a time, a developer came to a manager and asked him that he needs to refactor all project, rewrite all screens, and after that he will write all tests and everything will be cool. But manager asked this developer, why do we need to do so? And developer answered that our development will go with a plain speed and everything will be cool. And he will write tests after it, of course. Manager was excited about all this idea and decided, but what do you need developer for this thing? And developer answered that he needs a bunker and the months of time. Okay, sounds cool, only months of time. I think that you heard this kind of story, months of time, and all project will be rewritten and it will be cool. Okay, next, our developer locked up in the bunker and started to rewrite his code. But I have some question to this kind of developer. First question, why is this developer locked up in the bunker and why he didn't want to write any product features while this rewriting or refactoring or what is he is doing? And the second question, why he didn't want to write tests in the first place? Because he is rewriting the project. He already has some requirements for his project and he knows what to do with this. But he didn't want to do so. So, as you can imagine, the result of his rewriting stuff is a spaghetti monster on the screen, and he didn't make it within 1 month. It took from him maybe half of a year or something. But what did happen? Why he didn't make it? And why new code should be better than the previous one? This developer spent half of a year to rewrite in a code that was already written and already worked. So maybe just don't do anything, just to try to realize how the previous code works and don't waste time on it. But how do not make this mistake again? I think that our developer didn't understand what refactoring really is. And let me start with the definition. I found the simplest definition on the internet, and it sounds like refactoring is a control process of code improvements without creating new functionality, and as a result, a clean code and simple design. Okay, quite simple definition, I think. But I wanted to highlight some points of this definition. So the first thing, what refactoring is not. Maybe you keep an attention and realize that I'm mixing up these two terms, rewriting and refactoring, but they are different, and refactoring is not the same as rewriting. Because rewriting story is always a dead end, and when you rewrite your code, not refactoring, you could affect behavior of your application and could change it. And remember that our developer didn't want to write any tests. So it's quite easy to change something while you're just doing everything from scratch. So refactoring is not the same as rewriting. And also refactoring is not bug fixing. For me, bug fixing is the same like as creating new functionality. So while you create new functionality, you create new requirements for a project. You write new tests or you change the tests that you already have. So it's easy, I think. But what's the difference between refactoring and adding new functionality? There is a rule that called two heads. So the first head is the refactoring itself. When you put on refactoring head, you change in the structure of the project. However, you don't do any new functionality, and you already wrote some tests that are proof that you don't break anything. But refactoring head is another idea. You don't change the structure of code, but you create a new functionality, implementing new features, and as a proof that your feature works, you write some tests. But there is a trick that you can change these heads quite frequently. So for example, you need to write new feature, you put on functionality head, write in this feature for 10 or 20 minutes, put it off, put on refactoring head, and refactor all what you've done. However, it's not possible to wear two heads at once. You could try, but it's not very convenient, I think. So let me start with the base principles of refactoring. I do it on purpose before some techniques because you could not know any techniques at all, but while refactoring, you always could go back to the base principles and decide do you break them or not. So I think that you already mentioned that I'm talking a lot of tests. So the one of the base principles of refactoring are tests. In a perfect world, refactoring and tests is like the same stuff. You cannot just separate them. While changing some code, you need to be sure that you don't break anything, and tests should be proven of it. So tests are not bug catching. Tests are just a proof of working of your code. Also, tests are great documentation and improvement of your code readability. So tests could be a great way to simplify your code and make it better. Another base principle are small tests. Oh, sorry, small steps. Tests. Yeah, small steps. So remember my previous slide about two heads when I'm talking that you could change these heads every 10 minutes. So the same for refactoring. Refactoring never should be a purpose of writing code or changing it. It's just an instrument how to make your code better, and it never should be more than 20 or 30 minutes for one refactoring. So remember this guy in the bunker who wanted to try to refactor all code within a month. It's a bad idea. But why should we need to refactor? I found on the internet like 5, 10, 20 reasons why we should need to refactor. Even in my first iteration of this presentation, I wanted to put 4 of them. However, business only appreciate this idea on the slide. It's development acceleration. And only why we need to refactor because we start to code in faster. But for developers, it's also a kind of side effect because working in the better code are better for us, right? So if you wanted to sell refactoring to your management, just tell them that you will code faster. That's it. Okay, when we should refactor? The first point is the rule of 3. Rule of 3 is kind of brake pedal for the developer. But what does it mean? It means that the first time you just add your new functionality without any thoughts about refactoring. The second time you still add in some similar code, but don't do anything with it. And only on the third time you start your refactoring. So you shouldn't try to put over engineering on the first place. Just make your code work, and only after that try to think how to make it better. The second point is adding new functionality. Inattentive listeners could ask that I already told you that adding new functionality and refactoring are different things. However, attentive ones already know about two heads rule. And you remember that we could put on the refactoring head, make our code better, and after this put on the functionality head and start to implement new features. From my experience, even when I wanted to implement new feature, especially in a code what was written by a different developer on the code that I haven't seen like for half of a year, I do some small refactorings, just try to understand how the code works. It's quite good. So, and the next point is before bug fixing. I already told you that for me, bug fixing and adding new functionality are the same, so I don't want to waste any time on it. And opposite, when to refactor, I want to tell you when not to refactor. So the first point, when your code does not work. Some people over there are working in consultancy, on outsource, and working on some project that could be given them from another companies. And when you got this project, I think some already has an experience that this project doesn't build at all. You know, some private libraries or not the first commit on the master or something like that. And what to do in this? Not to refactor, of course. Just make this code works, and only after that try to make it better. The next point is our deadlines. I think deadlines never should be an excuse for a bad code, because everybody knows that a bad code is like a snowball. If your code debt more, then development slower. However, sometimes you have some 100% crashes on a real application, and you need to do something with it. You're not going to refactor your code, not going to do it better. You just implementing it, you just fix the crash, and make it into production. And the last point is there is no turning back. Imagine that you are working with code in an ancient spaghetti with 20 and 10 in the header, and no one understands how this code works, and developer is gone. So in this way, it's just a better idea to throw it away and write everything from scratch. However, there is always situation, but not when you write in an Objective-C, right? There's no situation when you cannot just apply some small refactorings and make your code better. So how to understand that you need to refactor your code? How Canbach's grandma says, if it stinks, change it. So now we're going to talk about code smells. Code smell is a surface indication that usually corresponds to a deeper problem in the code. On the slide, you can see a QR code. You can find some more code smells by this QR code. And on the last slide, there will be a QR code with all links in it. But I'm going to tell you about some deadly code smells that I found. OK, I'm waiting. Super. The first deadly sin is code duplication. Of course, rule of 3 working here perfectly. You shouldn't start refactor code until it works. However, I want to say you that duplication and copy-paste are different things. One thing, when you just copy and paste your code. You never should do something like this. But in some situation, you could have some similar code. And it's always better to refactor it and decrease your amount of code. Quite obviously, however, I see a lot of examples of code duplications in all projects. The next one are comments. I think that comments are quite holy war theme, and some people think that comments are a great idea because we could put comments, make code more readable, more simply to understand what is going on. But I'm in the second camp who thinks that comments are a bad idea. And I describe you why. So on the left part of the slide, you can see the function that's called assemble. I found it in some repo, in some project. It's not my code, of course. But you should understand what is going on here. We are creating some kind of module here, and assemble function created it. And in this module, we created parts of this model. For example, view. You should believe me, there are a lot of these parts, so I just decreased code to you to understand what is going on here. So what I've done, I put everything that under this comment and extracted in functions that called register view and replaced it with everything that was under the comment. So what I've got is the result. In the result, we have a simpler functional assemble where function doesn't know anything how to register its part. It just knows that view registered, interactor, presenter, whatever you want, and the developer who go back to this code shouldn't know how to register stuff. It's just registering, and it's simpler to understand. But I want to add that comments and documentation are a different thing. For example, comments, like on the slide, is just we're trying to understand how the code works, and we didn't write this code well. However, documentation for a public API is slightly different thing. When we need to provide our black box API to different developers, we need to write some documentation. In simple words, 2 slashes are bad, 3 slashes are good. Another code smell I just picked because of naming. What does it mean? Shotgun surgery. What does it mean? It means that one responsibility was shared between different entities. For example, you need to implement one simple task for 30 minutes, I think more or less. However, it's really 30 minutes. It's not like a bunker story. However, while implementing this feature, you need to go to a lot of places to implement this. So I think some architectures with a lot of letters in their names were things with shotgun surgery. So in simple way, it means that small feature, big amount of fixes. Just don't share responsibility between many entities. Another code smell, something big, but it's not one smell, it's kind of collection of smells, like big class, big function, big amount of parameters in this function, big tuple, and etc., etc. So it's quite opposite for the previous one. It means that we have a lot of responsibilities in one entity. And we need to separate one entity to many. But nowadays, we could use linters like SwiftLint just to indicate the smells automatically. And if we have like 5 parameters in the tuple, SwiftLint will tell us, whoa, whoa, hold on your horses, you need to fix it somehow. And how could we fix it? Now, we are going to talk about refactoring techniques. There are QR code. It would be on the last slide, but I wait. No, I wait, please, please, of course. So there are a list of these techniques, but I'm going to tell some of them. The first one, okay, cool. The first one is well naming. Super obvious presentation, yeah? But we all have bad code in the legacy project. How is it possible with all these simple techniques? So, well naming. Well naming helps us fight with the comments. Remember my example when I extracted a function, just named it well, and I don't need a comment. But how could we check that we named everything well? Cross-comment reviews. So if you have a teammate, but from another team in your company, you just need to ask this teammate to review your code. This teammate shouldn't know anything about your project, maybe something, but not about the code that you implemented. And if this person understands what is going on in your project, that means that you named everything well. Of course, it's not only about well naming. However, I think like the first and the must technique in the refactoring is well naming. Everything goes through there. The next collection of techniques called inlining techniques. What is it about? Like, as you see on the graph, it's when we have some entities and just inlining the one big entity. But for example, in the right part of slide, we have 2 computed properties. The first one more than 5 late deliveries, and the next one rating. So when it's easier to understand what is going on with function or with the property, just read the body of this property, like number of late deliveries more than 5. It's easier even to understand the name of it. So it means that we could just inline this property inside rating, and as I done. For me, it's quite easier to read it, but mostly all techniques in refactoring tell us make shorter functions, make them more simpler, and etc., etc. However, needless indirection is irritating, and one of the codes smells like shotgun surgery shows it to us. Something opposite for inlining techniques are extracting techniques. So here we're just taking some entities from entity and extract them. For example, we have a class or a structure or whatever that's called person. It has 3 parameters, name, office, area number and office number, and the function get telephone number. So I think that everybody here are quite experienced developers and understand that office area code and office number shouldn't be in the person because it's something about telephone, right? So we extracted it to two entities, one person and another one telephone number. And now our person just has a property telephone number. Let me tell you about some dark zone of inlining and extracting techniques. For example, you have already a big project with 3 or 4 architectures in it. And you need somehow to deal with it because like 3 architectures may be a lot. But what could you do? You could use inlining techniques, put everything in one place, and then use extracting techniques and extract everything whatever you want way. However, I never told you that. It's nothing about actually refactoring, and you never finish your stuff within 20 minutes. But if you have a couple of classes, it could be a great idea to do so. After some general techniques, let me show you some specific ones. Here we have a replace temp with query, sorry. Here we have a function that called calculate total. And inside this function, we have calculation of base price. However, my idea is that calculate total shouldn't know anything about base price and how to calculate base price. So I extracting it and replace all temporary with a query, base price query. But you could ask what it gives to us. I think that calculate total should be somewhere in an entity which deals with money. If it's not, I think that we should apply some other refactorings to do so, because it's calculate total, calculates money, it should be with money. So now we could reuse this base price. The second prong is our calculate total now smaller, and the third one is harder to make a mistake while doing something with the base price. Imagine that we have calculate total much bigger and we have different base prices aside if cases or something like that. Actually, after this in the demo, I will show you how it could help us more.
Slide. I mean, in the example on the right, base price could change by the time you get to the second return statement, right? Because if quantity or item price changes, then base price is going to
So if we work in one thread, it couldn't.
Okay.
Yeah, like base price is a calculated property, but if we don't change quantity or item price somewhere in the middle of calculate total, we don't have any problems, right?
Okay, but you could happen on a separate thread or something from something else, user input or something like that?
Yeah, but is it impossible only when we work with multi-threading? No? Because like
It
if...
would be possible on the left, because we declared the left
Yeah.
base price, then it would stay the same
Yeah.
throughout the function.
Yeah.
So you
On the right is mutable.
So you introduce a bug actually by this refactoring, that's what you say, right?
Well,
Possible bug, yes. But
and if you put some logic in between those two, the first if and the return, it's also dangerous. Right? Someone could come in and add some logic to accidentally change the quantity of the item price. You wouldn't know about it.
Quantity, yes, if I put it inside, of course. But you're thinking like in very general way. It's just like we have a one function and we refactor it in a smaller function, and don't imagine that we need to do something else.
I'm going outside.
But it's a good mark. I didn't think about it. But also in my demo, I will explain you why we shouldn't think about it in the first place. Another technique is replace a magic number with a symbolic constant. So here, there is no way to make a mistake here, right? But observing, I'm very appreciated. We have a formula of calculating circle area. I think everybody knows this formula, but if it's now, it's a formula of calculating circle area. So as a p number, I took 3.14. You see all spoilers, I should. But I imagine that our magic number 3.14. not about calculating circle area, but about calculating some coefficients for a reactive engine. And you will never like realize what does it mean just looking for a number. So what to do in this case? Just put all constants into the constants, or creating a temp variable like on the previous slide. It's actually also one of the refactoring techniques to do it in vice versa way. For example, I think tests are quite good example for it. Sometimes we need to stop some numbers and we put something like 5 in a test because we don't care about this number, but every reviewer should ask, why do we have 5, not 10? And you will never ask it. Better to name somehow your numbers in your code if you use numbers. So finish with techniques. And I think that one of the questions could be that I already have a project. It's a big, ugly project, and what could I do with it? Because with your small refactorings, I never finish our project, and it always will be bad. But imagine that your bad project is bad, ugly tree with a legacy inside. It's rectangle, and I'm not a painter, so rectangle is a tree. Just imagine it. And step by step, with small refactorings, you're starting to grow in the small good tree, the green rectangle. But you grow in this tree, just cutting pieces from the old one. And in the end, somewhere, sometime, in the end, your green and good tree will absorb the bad one. And you will have the only cool code in your project. But I think that's quite a utopia, but still only this way I can see how to refactor big project. Demo. So now, how to change it? Cool. Not cool. You cannot see it, right? Can you see it? And now? OK. So now I will show you a little bit how to use all this stuff. So for init values, we have 3 classes. One of them movie, with the types of movie, title, price code, a rental, which includes movie and days of rented, and a customer, our main lead of this demo. So customer has a name and multiply rentals. But our customer has a function inside that call statement. This big guy even doesn't fit on the screen. But this statement just shows like some information about rentals. So looking at this code, please somebody tell me how could we refactor it? Okay, who else? Okay, other ideas? So it's all code, nothing there. We will write tests. So firstly, I should stop it because firstly, before start to refactor in your code, you should write tests. All presentation was about it. But OK. What? OK. So there is a test. It works. And the first idea, I heard it, like extracting the enum, because it's under a comment, and switch is quite like an external function. I don't even try to write any code here because Playground always fails. So we just extracted all switch to separate function without any renamings in it. And our tests still works. So we're sure that we didn't break anything while refactoring. It's the main point of all refactoring, just to make any code changes and don't think that we could break something. So inside this function, we still have this strange naming like each and this amount. Maybe we could rename it to rental and result. Remember, another principle are small steps. So we renamed it. I could run code from here. We renamed it. Our test is still going on. We renamed it, and now it's more readable. But we can see that inside of this function, everything that we do is only related to the rental itself, nothing about customer. So maybe we could just move this function to the entity rental. And before doing this, I wrote another test. So, and skip one step, I just renamed this function, but now it's called charge, and it's inside rental. You see the statement function already fits on our screen. We already achieved something. And it should be quite more readable. So another point, changing our temporary variables with the queries. And we will change this amount to each dot charge. Because in this particular point, we don't even rely on it at all. Let me check tests. They're still working, 2 of them. Oh, it's smaller and smaller all the time. But what else we could do with this code? We have like this big variable that every line under the comment and something going on here. And when we realize what is really going on, it just means that relied on movie type of the rental. We just took 1 or 2. That's it. So maybe we could move this variable to, thank you, it stopped. Yeah, sometimes it happens. Never use playgrounds, they are bad. So I'm going to skip this step. Here. So we moved our frequent rental points here, and the next step, here we calculated total charge and total frequent rental. I never pronounce it, but this thing, and now I'm extracted it to different 2 properties. But I have another question for you. So how do you think? Is it okay to keep in the function like actually 3, 4 loops in the same place? Because before everything calculating in 1 for loop, but now it's calculating 3 loops. How do you think? No? Just tell why.
I will call the functions inside of for loop.
Okay.
So a function acts on
But why is it bad?
takes time.
Yeah. Have you heard of the guy? His name is Donald Knuth. So he told us that premature optimization is the root of all evil. So actually here, yeah, it could be the next step of the refactoring, but remember small steps. Actually here we achieve the better reading code. It's simpler. So why should I be bothered about like some 3 loops because I'm just calculating small strings? I don't think that our user will have a lot of rentals, but when after only this I will start some optimizations. Our optimizations never cause of better code. So we should do our optimizations only when we achieve good code. Excuse me? Yes, yes. Yeah, it could be reduced. it could be just a reduce, not a for each, of course, but it could be another step of refactoring, right? Because in the initial statement function, we have a for each, and we just starting, to implementing, to put it here and there. And one of the refactoring points or steps, we could replace this for each with a reduce. So let me finish our refactoring of this function here. I know that there are a lot of things that we could do, but remember that we should produce some features. And this statement, it only gives us just a plain string. But we live in a new era, and maybe another statement should provide an HTML page for it. And what could we do with this situation? We will write another statement and call it HTML statement. I wrote test. I'm going to, hold on. They going. I'm not going to try it again. But there is a result of all this refactoring and everything what we're talking about. With the small steps, maybe sometimes you don't even understand why do we need to do so. Because why do I have to extract this? It was OK here. But now when we implement new functions, all our simple code will give us some opportunities to implement new features. That's it for demo. And let me continue to the presentation. Actually, it's happy end for our developer. He breaks through the bunker, and now he knows what refactoring is. But let me make some summary what we were talking about today. So we were talking about what refactoring really is, what's the difference between refactoring and adding new functionality, when to refactor, how to detect what to refactor with the code smells, and refactoring techniques. So here is a QR code with all links that are used here and with some literature. There is my contacts. I know the Telegram not very high use here. However, you can find me with this nickname everywhere where you want, and my GitHub. Thank you. And question, please. No. Yeah?
How we can refactor UI implementation? If you create UI view and configure UI view.
Yeah, I forgot to tell, one of the main lines of this presentation should be when we have a bad untestable project and we couldn't do anything with it, we could write some tests like UI tests, for example, just to test it. So when we refactor UI, actually there are snapshot testing. I understand that very few of people write some UI tests and snapshot testing. However, if we want to create very stable project, we could use these techniques. Please.
We can also use performance testing for refactoring to see if the code is still performing as fast as it was before.
So if you have a goal to keep the same performance, of course you can. But for my experience, I understand all these algorithms and big O and all this very valuable, but for the main projects when, for example, it was in demo, when I put 3-4 loops, nothing changes because we already have 4 cores, processors, and everything. But of course, if you're doing some game, you need to calculate it. But usually it's not so quite necessary. Okay?
Regarding your slide, when not to refactor, there are always external circumstances. For example, the code could be so complicated that the crashes can only be fixed by refactoring the whole bloody thing. Like you have a view controller with a view controller, and a whole series of stuff that's interrelated. It's a mess, it crashes, and the only thing way you can solve it is basically rethinking the whole setup, and in that case, fix the bug.
That would be bug fixing.
Yes, but you bug fix it by refactoring, by creating a whole new paradigm. So
But it's not a... Oh, you're so sweet, guys.
rewriting, but it's also refactoring. Or not?
You didn't have any attention to this.
Yeah, true. Another thing that doesn't that you don't take into account is deadlines and real stakeholders. So you say, never write bad code. But you have a demo tomorrow and this feature need to be in, otherwise the whole $1 million funding will fail. What do you do?
But there is a actually no, there is an actually yeah, there is an actually point of if you have a deadline, you should stop to refactor and just do what you need to do. And if you're losing $1 million, it's like something the same that you have crashes on production, right? So you just need to put some attention. But sometimes, and from my experience, some managers just want to accelerate the development and say, oh, you don't need this refactoring, you don't need to do this, you don't need to do that. But as an engineer, you should always understand that right now we will write bad code, okay, for this feature. But after this, we need to handle it somehow because it was slower and slower product. And sometimes I came to the companies and they show me, oh, it was only a prototype, but now we need to somehow handle it. And one small feature just to change sections in this table view takes 1 day. So there is, of course, we should think all the time. Yes, technical debt. Thank you.
Technical debt is intentional. Technical debt is intentional. I mean, you just get in debt just to get it some immediate return. If you're writing bad code, it's bad code, not technical debt.
Yes, we could think in this way.
One leads to the other.
Not necessarily. No. I mean, either you're writing intentionally bad code, this is bad engineering. Technical debt is just getting an intentional gain just for sacrificing your code quality. For example, you're just getting like $1 million of contract just for writing bad code. That's an intentional move, so it's technical debt. But if you can't create a good abstraction, that's bad engineering.
What if you inherit a project that's 5 years old?
That's blaming others. I mean, you can just name it whatever you want, but still, bad code is bad code. It's legacy. I don't like the term legacy. For me, it's like vintage code.
Someone told me a nice definition of legacy code, and that is legacy code that is not refactored. If you have code that is not refactored and does not have a proper set of unit tests, then it is called legacy code. So legacy code can be actively written, but if it is not...
I mean, legacy gives an impression that it's old, but if that code gives you $100 million a month, it's production code. So
it's a cash cow, but it is still cement code.
That's business, right?
Any questions related to the presentation? Okay, please.
You started with writing unit tests.
Yeah.
But what if you need to refactor to be able to write unit tests?
So I already actually answered on this question. If your code is untestable at all, you need to write at least integration test or at least UI tests just to prove that you don't break, the big functionality. So of course, if you cannot write a test, how could you write tests, right? So you need to do something just to be sure that everything all right. At least give your QA engineer, just try it. I didn't break anything, please. Something like that. Yeah.
How would you do it in practice? For example, in the example that you showed, would you draw a kind of data model on paper, like a class with all the methods, these kind of things, or would you do it directly in code?
Well, of course, I won't write anything, draw anything. About the refactoring itself, so it's always small steps, and usually it's unintentional refactoring. So usually, I need to refactor. No, it's for me, it's in rare cases, it works like that. Usually I open code and start to understand how to implement new feature. And while understanding how code works, I start to refactor in it with small, changing name, extract the small function to this function. When I see that I need to add some features in this particular place, I review my tests, see my types, because usually you need to add some function, just place fatal error inside, write tests for it. and refactor everything outside to reuse some other code from everywhere. So kind of it. Did I?
I'm new in this environment, but I'm already doing 20 years of Java. And what I always do is, like let's say 10 minutes it takes me to write a piece of code, one or two unit tests. And at the same moment, let's say 2 or 3 minutes, I do some refactoring to clean up the code before I go to implement the next feature. And it is my experience that it is quite handy to do it this way, because if you have just written the code, you all have the nitty-gritties of what you did. It is still in your head, and at that moment you see the most possibilities to do some cleanup. So it is just a matter of writing a test, writing some code to implement it, do the refactoring, and if it is refactored, then you do a commit, and you will go on to the next feature. So it is a matter of stages of like in every quarter of an hour, you can do some refactoring, and it just when you do it just after you wrote the code, it takes you 2 or 3 minutes to refactor it. And then it is not the big refactorings that you did here, but they can be even smaller. Optimize names, maybe
Yeah.
take out some functions or whatever.
So actually, thank you. So actually, you just did describe the two heads rule. So two heads rule, remember it? Like functionality head and refactoring. So you could change them like really every 2 minutes. Just add some functionality, put on refactoring. Yeah, you could refactor a code before like even committing it, you know? So it,
Yeah, for example, if you start with a spaghetti code,
yeah,
which typically is not encapsulated in classes and stuff, it's
Yeah.
just line by line. That takes some kind of thinking, because you have to start thinking, okay, which classes I have to make, which kind of methods in which class, which kind of.
but you don't do anything while this process. You just reading the code, right? You didn't change anything. So main idea not to try to go deep inside refactoring, you know, and make a refactoring like as a main idea of all creating code, you know. You shouldn't refactor only because of refactoring. You should refactor because of implementing new features. That's it.
Yeah, and also because of if you have a code of 4,000 lines, it's unreadable.
Yeah.
Especially if it's line by line, so you want to organize it somehow.
It's refactoring.
Yeah.
Organizing code is refactoring. So it's one of the refactoring techniques, you know. If you have like 2,000 lines of view controller, you could put something in the extensions at least, yeah. And it's small refactoring, right? I see this couple of functions working for this responsibility. I put in them in an extension. So it's small refactoring still. And after that, we could create like some different classes or structures and move these responsibilities.
I had to sometimes declare methods, functions that are 200 or 300 lines long. And when I do that often in that situation is that from the beginning you take the shortest path. What is the shortest cut to leave the method?
Yeah.
Probably that is just a no test or no value test. That is not going to fail on this no test. What is the next shortest path? And we create again a test on it. At the end, I know what is going on in the code because I wrote everything into code. Building up from the shortest path to the next shortest path to the next shortest path. That is a whole lot of work, but at the end, you know what the code is doing, and then you can start because then you have a set of root unit tests, and you can start refactoring and do some bug fixing or adding some features or whatever. But at least then it costs a lot of time, and sometimes you will scream at your former developers, why did you made a good unit test on it? But at the end, you have some code that you can say this is working. Sorry? Yeah, red, green, yellow. Yes, I saw all also possible. Yeah. But I have to learn a lot from you. But that's
Any other questions?
Last one.
Another question with Mark.
Could you speak a little bit louder? Sorry.
Another question with Mark.
Okay.
By the way, thanks for the presentation.
Thank you.
What I really miss in this refactoring presentations or refactoring demos is actually what is the simplest unit you're trying to achieve and why. For example, you're trying to achieve simpler functions or shorter functions, but in the case, what is the real thing you're trying to achieve? A shorter function or more functions, or what are you trying to do? For example, I was expecting some kind of ground rule saying what we're trying to do is actually eliminating side effects, which is actually the core reason of your refactoring, because then you can actually start testing properly. In that case, for example, the examples I was just saying, we just pretty far just trying to reduce the number of, this is not it. I mean, the functions we're actually reducing, smaller functions,
Yeah.
are they having side effects from that? Or are you trying to achieve that by refactoring? That was the thing I was missing. I mean, by breaking down bigger functions and smaller ones, what are you trying to achieve? Are you trying to achieve shorter line of code or some kind of abstraction or what? Because that's what I see. I mean, it's quite a discipline.
Okay. I think that I got a question. So,
It's not a question, it's a mark.
mark that I will answer on this mark. So actually, there is no point to achieve shorter functions or purer functions or another kind of functions because there are so many paradigms in programming. You know, object-oriented programming, we separated everything in classes, you know, inheritance and everything. Functional programming, where we actually trying to create pure functions with input and output, and like it's easier to test sometimes, but like there is no even like achievement in the code. What does it mean? It's very, you know, a theoretical question, I think, for me at least, because we have some code smells like shotgun surgery, yeah? Short functions are bad in this case because like they're too short and there is no even necessary this shortage. But on the other hand, we have like big class, code smell, where they're super big. Now we need to make it smaller. So there is never no right answer what we want to achieve. We want to achieve simple code that's easier to maintain. That's a goal.
My point is, a simple code is more functional.
It's for you, you know, because there is always like two camps, you know, like it's more functions, but for some people it's easier to write everything in one view controller because they don't gain such experience to handle a lot of classes. So for them, put everything in one place and just like put some marks in code. No, it's easier to maintain this code. So it's always an answer for each developer or for developer teams.